The next type of bond that we will discuss are covalent bonds. Covalent bonds are chemical bonds that are formed when two atoms share electrons, and this usually occurs between nonmetals. The force that holds these atoms together is the attraction of the atom's nucleus for the shared pair of electrons. So unlike ionic bonding, in covalent bonding, electrons are not transferred, they're not given or received, they are shared. A molecule, which we have discussed before, is a neutral group of atoms that are joined by covalent bonds. And a molecular compound is a compound, right? We know that it has, it's chemically combined and it's composed of molecules. So a molecular compound, a covalently bonded molecular compound, has some characteristics, including low melting and boiling points, which means that these bonds are not as strong as ionic bonding because remember, they have a high melting point. So covalent bonds, the process of sharing electrons, creates a slightly weaker bond than ionic bonding. They also do not conduct electrical current when they are melted or dissolved in water. Let's take a look at two examples of covalently bonded compounds. The first of which is water, something we are very familiar with. We know that water is composed of two hydrogens, and we know that each one has one valence electron and one oxygen, and we know that it has 6 valence electrons. Water bonds because the hydrogen here and the hydrogen here each need one more electron to have a full energy level, and the oxygen needs 2 more valence electrons, so they actually share their valence electrons, which creates this bond. Looking at another example, we've got ammonia, and ammonia is consisting of 1 nitrogen and 3 hydrogens. So I've drawn them here. And we know because of our shortcuts that, again, hydrogen has 1 valence electron, so each prefers to get 1 more for a full valence electron energy level. And nitrogen, we can see here, has 1, 2, 3, 4, and 5 valence electrons. So it will go through the same process, and each of the hydrogens shares one of its electrons with the nitrogen, and the nitrogen in turn shares one of its electrons, so that we have a bonding situation like this. It's important to look at diagrams like this so that we know which atoms are actually bonded to each other. If we did not know this, then we might assume that the nitrogen was bonded to one hydrogen, which was then bonded to the other hydrogens. But in fact, because of the covalent bond, the need to share those electrons, the hydrogen atoms are individually, the nucleus of each hydrogen atom is attracted to the nucleus of the nitrogen atom. And the same is true for the hydrogen and oxygen in water. It's also important to note that more than one electron may be shared between two given atoms. For example, you may have a double bond. An example of a double bond is oxygen that we breathe, called O2. And please notice for all of these that the subscript has been indicated here. In this case, we know that oxygen each has 6 valence electrons. And what we can see here is that they are sharing 2 pairs of electrons here in order to create a full energy level for both of those individual atoms. So this is one double bond. Here we could see that we have 2 double bonds occurring between carbon dioxide. We know that carbon only has 4 valence electrons, meaning that it needs 4 more. each oxygen needs two more, and so through the process of two double bonds, we're able to fill those energy levels. Sometimes you may see here that it's represented with the double line. The double line is representing the fact that they are sharing a pair of electrons rather than simply one electron. Finally, this is an example of a triple bond. Here we have nitrogen, which has 5, so N2. In order to fill the energy level, each one needs 3 electrons, so they are sharing 3 pairs and would be represented like this. We have discussed in class before that sometimes there may be unequal sharing of electrons. Just like friends or brothers and sisters may not share toys equally, some electrons are not shared equally between atoms. This causes the bonded atoms to have slight electrical charges due to the fact that one of the atoms pulls the electrons toward it more often, and so it's not equally shared. A polar bond is one in which the covalent bond is an unequal one, in which electrons are shared unequally. A nonpolar bond is one in which covalent bonds between the atoms are shared equally. The electrons are not pulled more dramatically to one atom than to the other. An example of a nonpolar molecule, so one where they are shared equally, would be fluorine, F2. We have two fluorine atoms. They are sharing an electron, and both of them are equal sizes. They both equally need that electron pair, and so they have an equal pull, meaning that it's being shared equally. A polar molecule would be hydrogen fluoride, represented HF. Here we have hydrogen and fluorine. It's an unequal pull because the fluorine actually is in greater need. It's bigger than the hydrogen, and so the unequal pull, you can see I drew a longer red line here representing the fluorine to show that the electrons are pulled toward, it says oxygen here, it's supposed to say fluorine. So noting the difference between them. This leads to examining why water and oil do not mix. You may have noticed when you were helping do chores and washing the dishes that it was a little difficult to wash oil or grease off of a plate or a dish with simply water. You actually need some dish soap. Well, there's a good reason, and it has to do with polar and nonpolar bonds. Oil molecules are nonpolar, meaning that electrons are shared equally in the covalent bond, and they have little attraction for the polar water molecules. And while water molecules are more slightly attracted to one another than the nonpolar molecules of oil are, which means that they are not ever going to mix. We actually need the detergent, which includes nonpolar covalent bonds as well as ionic bonds, which ultimately allow the oil and the water to mix and allow for your plate to get clean of grease or oil. So the next time you are asked to wash dishes, you can inform your parents about the information you have learned about covalent bonding and the reason why oil and water do not mix.